Welding and bonding techniques offer a wide variety of excellent joining and assembly options. In many applications, they provide the only viable methods of assembly. Both of these methods provide permanent bonds. So avoid welding and bonding when using material that will have to be separated for recycling or repair, or when less expensive joining methods are suffice. So when design when you must weld or bond, minimize the mix of technique and equipment used. So this session we will deal with the broader aspect of welding and bonding and their effects on the parts on and assembly design. So common welding methods including ultrasonic, vibration, hot plate, spin welding, solvent, and additive bonding. We will look at the ultrasonic bonding. So ultrasonic welding. Ultrasonic welding is one of the most widely used joining techniques. It is an excellent bonding method for thermoplastic. So it makes permanent fusing joints at relatively high rates of speed. So in this welding technique, an ultrasonic assembly unit generates mechanical vibratory energy at ultrasonic frequencies. The ultrasonic vibrational energy is transmitted through one of the melting parts to the joint area where frictional heating melts the plastic and forms a weld. When designing parts that will be ultrasonic welding, we need to consider the following, which is for strong, consistent welds, ultrasonic joint need properly designed energy directors or shear weld features. The equipment size and welding horn design limitation determine the size and number of ultrasonic welds per operation. Melting material must be compatible and rigid enough to transmit the ultrasonic energy to the joint area, and stray welding energy can damage free-stranding features and delicate components. So let's look at the video about ultrasonic welding.
Application, advantages and disadvantages with its diagram. Ultrasonic welding is a welding process in which ultrasonic waves or vibrations are used to generate welding. Ultrasonic vibration waves have frequency above the normal ear length. It is about 20,000 to 30,000 Hz. It is a solid-state welding process. Solid-state welding is a welding process in which no external heat is added for welding. It works on the basic principle of energy of ultrasonic waves. Ultrasonic vibration creates a dynamic shear stress between the contacts of two workpieces. Due to local plastic deformation and heat generated due to friction between contact surfaces, joint formation will take place at the interface. Now let's talk about the equipment used in ultrasonic welding process. First is power supply. Ultrasonic welding needs high frequency and high voltage power supply. This power is needed by the transducer to generate vibration. Second is transducer. Transducer is a device which can convert high frequency electric signal into high frequency mechanical vibration. This is connected with the welding head, the converter or piezoelectric transducer used in this welding process. Third is booster and horn. The mechanical vibration created by the transducer is supplied to the booster, which amplifies this vibration and supplied to the horn. Horn is a device which supplies an amplified vibration to the welding plate. Horn is fixture and clamping devices. This device is essential in the ultrasonic welding. It is used either electrical, hydraulic, pneumatic, or mechanical energy to hold the plate in its desired location. Now we know the basic concept of ultrasonic welding. Let's see the working of ultrasonic welding. To start, high-frequency current passes through a piezoelectric transducer. This transducer converts high-frequency electrical signal into mechanical vibration. This vibration further supplied to the booster, which amplifies its frequency. The amplified high-frequency vibration passes through horn, which is in contact with welding plate. This welding creates lap joints. One plant of the weld is fixed into fixture and other one is in direct contact with horn. These plates are fixed under moderate pressure force. The horn supply high-frequency mechanical vibration to the welding plate. Due to this vibration, oscillation shear force act at the interface between welding plates, which result in plastic deformation at interface. They also create a localized temperature rise due to mechanical force and friction. This helps in plastic deformation at interface and makes a strong joint without melting a work piece or using filler metal. Let's talk about its advantages, disadvantages, and applications. Advantages. This welding can be easily automated and fast. This produces high-strength joints without applying external heat. This is clean and provides good surface finish after welding. Ultrasonic process used to weld wide variety of similar metals. It does not develop high heat, so there is no chance of expel molten metal form joints. Disadvantages. It does not weld thick, harder metal. The thickness of weld is about 2.5 millimeters for aluminum. Tooling cost for fixture is high, and they also need special design. The vibration generated through transducer can damage electronic components. Applications. This welding is used in fabrication of nuclear reactor components. It is used in automotive industry for heat, headlamp parts, buttons, and switches, etc. Ultrasonic is used in electronic industries like armature winding, switches, etc. This is clean welding process, so it is used in medical industries to make parts like filters, masks, etc. This is all about ultrasonic welding process. If you have any query regarding this video, ask us by commenting.
See about vibration and hot plate welding. So if you want to form a continuous welds over large areas, so we can use a vibration and hot plate welding that cannot be used by using ultrasonic welding. So in vibration and hot plate welding, a friction welding technique, vibration welding requires wide joint surface to accommodate the sliding vibration. So to avoid dampening the vibration, part geometry must rigidly support the mating joint surfaces first. In this process, one part remains stationary and the second vibrates on the joint plane and generating the heat. Means that one part is immobile and the second part is mobile, which is it only vibrates at the joint plane. So the vibration, the part that vibrate will generate heat. When the joint interface reaches a melted state, the parts are aligned and clamped until the bond has set. So for permanent non-cosmetic welds along a single plane, hot plate welding offers an economical joining method. In this joining method, a heated platen contacts two plastic parts until the joint area melts slightly. And the platen retracts and the parts are then pressed together until the bond sets. So both techniques can produce flash or a bead along the joint when applied to simple butt weld configuration. So look at this image. This is the butt joint weld result in flash along the joint. Okay. This is a before and after the welding technique. So this figure is the variation with flash, okay, flash traps. Okay, but is the joint welds result in flash along the joint. So this is the flash or bead. Okay, flash or bead. So this figure is about the variation of flash trap. So we can see this is the flash trap here. Flash trap to avoid visible welding flash. So this is the before and after. Okay. Consider the joint design with flash trap for application requiring flash-free joint. Vibration welding. One part is static and one part is smooth. It is very easy to use and suitable for application of large parts that cannot be used by ultrasonic. So let's see the example of hot plate welding. Okay, we will proceed with spin welding machine. This is the example of video for spin welding machine for plastic bar. So spin welding machine is used extensively to weld circular part with continuous joint, which is part which have a circle shape. It relies on frictional heat generated between mating parts, one spinning and one stationary. So this part will spin and this one remains static to melt a plastic in a circular joint. So after the friction melts a sufficient amount of plastic in the joint, the rotating stops and pressure increase to distribute melted material and complete the bonding process. So part designed for spin welding often have an alignment feature. Joint for spin welding can also include flash trap to avoid visible welding flash. So we can see the attachment of these two parts for water jar. So now you know how to use a